Hey guys, this is Mrs. Tran-Bloom. Welcome back to another chapter of trigonometry. This is actually the last chapter for the entire year. You can do your happy dance. Yay, yay. Okay, so I am in charge of recording this unit. So before I start, I'm actually going to write my name on here, Mrs. T. Bloom, and for recording. All right. Okay, so the first thing we're going to talk about is your whatchamacallit, the right triangle trigonometry, which for 8.1 we kind of merge that with chapter 6 because that's what we call the baby trigonometry. The only thing that we didn't study in 8.1, most of 8.1 is already done with chapter 6. The only thing that we didn't do in 8.1 was the complementary angle theorem, in which we're going to talk about today. But before we start the notes, let me give you a joke, right? Here we go. Here's my toddler joke. As you know, I have 4-year-olds. What do you call a pig that knows karate? What do you call a pig that knows karate? A pork chop. Hiya! One of my kids want to be a ninja when she grows up, so that kind of reminds me of her. Anyway, first I'm going to define the definition for us. We're going to define complementary angle theorem. So complementary, as you remember in geometry, complementary angles are when the two angles, when they add up to be 90 degrees, okay? So the theorem says cofunctions of complementary angles are equal. Okay, so let's talk about the definition and what it means. So there's a little space on here. I'm going to ask you to write this out for me. I'm going to ask you to write sine of 30 degrees. And I would love for you to fill that out for me. Sine of 30 degrees. Sine of 30 degrees. Okay, I'm going to leave it blank. And I'm hoping that you already have the answer on there. I'm going to ask you to write cosine of 30 degrees. Okay, again, I'm going to leave it blank because you are supposed to have it. Then what I'm going to do is I'm going to write over here sine of 60 degrees. I would love for you to fill that out. And cosine of 60 degrees. Okay, by now you should know these questions or these angles really, really well. If you don't, then I'm seriously, you are struggling with trigonometry if you don't know this stuff by now. Alright, so if we are looking at sine of 30, hopefully you guys wrote down 1/2. Okay. If we're looking at cosine of 30 degrees, hopefully you guys wrote down rad 3 over 2. Now let's look at these two angles. Are these, if I add them together, are those two angles, do they add up to 90 degrees? No, they don't add up to 90 degrees. So therefore, they are not complementary angles, okay? Now sine of 60 degrees, it's going to be rad 3 over 2. And hopefully that's what you have in your paper. And cosine of 60 degrees is going to be 1/2. Alright? So now look at this. Which two are the same? Cosine of 30 degrees and sine of 60 degrees, they have equal answers, or the same answer. Sine of 30 and cosine of 60, they have the same answer. So because 60 degrees and 30 degrees, when I add those two angles up, they are 90. Right? Similarly to here, that's what we call a complementary angle, right? Because when they add up to be 90 degrees. So with that said, okay, so I'm going to give you this right triangle, and we know it's right because I'm going to put a box right there. Either I put a box or I tell you, see, it's the right angle. So based on the theorem, it says, hey, sine of B, which is this angle right here, based on our complementary angle, sine is opposite over hypotenuse. So we're going to say B over C, opposite over hypotenuse, should be the same as which angle? Should be the same as cosine of A, because cosine of A is also adjacent, which is B over hypotenuse, equals to cosine of A, which is also the same, adjacent over hypotenuse. Okay, so because if this is 90, the only two angles left are A and B, then they have to add up to be 90. So if that's the case, it's gonna follow our complementary angle theorem. So that means sine of B equals to cosine of A. Okay. So cosine of B, which is, I'm going to focus on this angle, cosine is adjacent over hypotenuse, so it's going to be A over C, should be equivalent to something that has A over C as well, which is going to be sine of A. Okay. Tangent, we're going to work on tangent of B. Tangent is opposite over adjacent, so that's going to be B over A, opposite over adjacent. It should be equivalent to cotangent of some angle, which is also cotangent is going to be adjacent over opposite, so we're going to look at angle A. Okay, so notice these relationships. Cosecant of B, so here's B. Cosecant is the reciprocal of sine, so I'm just going to flip C over B. Now, which relationship has C over B? That's not cosecant, okay? So C over B. So if we're looking at it, we can say that is the relationship angle A of secant. Okay, so secant of angle A. Well, secant of angle B is going to be hypotenuse over adjacent, or you can just flip cosine. So C over A. So secant of angle B is C over A, which is equivalent to something of angle A. Can you tell me which one it is? Something has C over A. That would be the opposite relationship, which is going to be cosecant. Okay. Cotangent of B is the reciprocal of tangent. So technically, I can just write A over B. Okay. Then this is equivalent to tangent of angle A. Okay. So now that we know what a complementary angle is, we can find the rest. So let's see how long. Looks like this is our only page for today's video notes. Okay. Moving on up. Okay. All right, and again, if honestly, if I'm going too fast and you're not done writing, you do need to pause and finish writing. Okay. Don't move on just because I'm moving on. And please write down the stuff that I'm saying, otherwise it's not going to make sense to you. All right, here we go. Example 1, using the complementary angle theorem to fill in the blanks. I got A and I got B. Without the calculator, okay? Remember, you cannot use a calculator unless in the direction it says use a calculator or use a graphing utility. So what we're going to do is find the value of sine of 9 degrees. Based on our complementary angles theorem, we're going to say that what other angle adds up, okay, to be 90. So 9 plus blank equals 90. So I'm going to fill in my blank. I can't speak. My blank. So 9 plus 81 degrees, 9 degrees plus 81 degrees is going to be 90 degrees. So I'm going to write 81 degrees first. Well, sine of 9 degrees, okay, let's go back to sine. Sine of one angle B equals the cosine of its complementary. So I'm going to write cosine of 81. Okay, that's what these type of problems want us to do. All right, so we're going to write part B, tangent of pi over 12 equal to what? We're going to go back to our tangent. Okay, so tangent of some angle A equals to cotangent of its complementary. So I know I'm going to be using cotangent. The question is, what angle, okay? Because it has radians here, this right here needs to be in radians. This is degrees, so this needs to be in degrees, okay? So pi over 2 is equivalent to 90 degrees. We know that much, okay? So what I have here is pi over 12 plus blank equals to 90 degrees, but in radians, we're going to use pi over 2. So what we're going to do is we're going to find the LCD. Pi over 12, this is pi over 2. The common denominator is obviously 12. So I'm going to multiply this by 6, multiply it by 6. So this pi over 12 is equivalent to, as you know, 12 here and 6 pi here. So what do I need to add to give me 6 over 12, which I need to move over so you can see. There you go. So pi over 12 plus blank equals 6 over 12. So we're going to write in the blank spot 5 pi over 12. I cannot reduce this. This is my complementary angle. Okay, so cotangent of 5 pi over 12. So tangent of pi over 12 is identical to cotangent of 5 pi over 12. And again, if you need to write stuff down, like what I'm saying or the scratch work, then you need to do that so you can understand why we do what we do. Okay, example 2, find the exact value. That means no calculator whatsoever, right? Here we go, zooming in so you can see. A, sine of 28 degrees, take away cosine of 62 degrees. Sine of 28 degrees and cosine 62 degrees are both on the unit circle. They're just not one of the angles that we know how to calculate with that one. It's not a 30, it's not a 60, it's not a 45, it's not a 90, or multiple of those things, okay? So, but we do know, okay? We do know now how to find it using a complementary angle. If I add 28 and 62, I know that 28 plus 62 equals 90 degrees. So I know these two are complementary angles. That means I can use my theorem. Sine of 28 degrees, okay, I'm going to write this down. I'm not going to do anything to this. But cosine of 62 degrees, based on my complementary angle, states that it's the same thing as sine of 28 degrees. Okay? Again, cosine of 62 degrees based on my complementary angle is identical to sine of 28 degrees. So sine of 28 degrees, take away sine of 28 degrees equals to nothing, 0. And that is my final answer. Okay? Another way that we can do that is I can change sine of 28 degrees into cosine of 62 degrees. So sine of 28 degrees is cosine of 62 degrees based on my complementary angle theorem. Then if I'm going to take away cosine of 62 degrees, that's also going to be 0. You only need to change one of these. Okay? If you change both of them, then you're just going to go in circles. So just change one of them. Alright, moving on down. Cosine of 35 degrees divided by sine of 55 degrees. I cannot do this right now or before this lecture without a calculator. But now that we now know the complementary angle theorem, we can work this out with that one. 35 plus 55, that is exactly 90 degrees. So I can use my complementary angle theorem. I'm going to say, hey, you know what? Cosine of 35 is the same as sine of 55 degrees. Well, sine of 55 degrees divided by sine of 55 degrees is going to give me an answer of 1. Okay? And again, you can change the denominator as well. You can say, hey, sine of 55 is the same. Work that out for you. Sine of 55 degrees on the denominator is the same as cosine of 35 degrees based on my complementary angle theorem. Then if cosine is what I have on the numerator, divided by cosine of 35, that also equals to 1. Okay? So it doesn't matter which angle you change, you should always have the same solution. Alright, we're on our last piece of today's video, which is secant of 24 degrees, cosecant of 66 degrees, okay, multiplying together, take away tangent of 24 degrees, times cotangent of 66 degrees. Now, if you take 24 degrees add to 66, that is exactly 90 degrees. Okay. So I'm going to change, I know I'm going to try to put this right here into, right now I can either make secant into cosecant. Let's just do that because that's what, okay. So let's look at our relationship in terms of what I want to change secant into cosecant. So secant of angle B is the same as cosecant of angle A. So I'm going to take this out and said, hey, according to my theorem, secant of 24 equals to cosecant 90 subtract 24 is 66 degrees. Bring this down, multiply to cosecant of 66 degrees. Oops, I wrote 60, but I meant 66. Right? So right now I have cosecant of 66 because I changed that times cosecant of 66. Take away. I'm going to change tangent of 24 degrees, okay, to cotangent. So tangent is equivalent to cotangent 90 subtract 24 is 66 times, or bring down cotangent of 66 degrees again. Moving over so you guys can see that. I'm now just going to multiply these. Cosecant of 66 degrees times cosecant of 66 degrees is cosecant square of 66 degrees. Do not put the square behind the 66 degrees. That means you're just squaring the 66 degrees itself, not the so if you want to say that these things twice, then put it behind the cosecant or the trig term. Take away cotangent of 66 degrees times cotangent of 66 degrees. I just have cotangent square of 66 degrees. 66 and 66, they're both the same angle, so I'm pretty sure there's an identity for that. Okay, so the identity I'm actually going to use is tangent. No, that's cotangent. Okay, so cotangent of theta. Cotangent, sorry, can you guys see that? C-O-T. Cotangent square of theta plus 1 equals to cosecant square of theta. I'm so sorry. I'm writing. It's such a mess. Cosecant square of theta. And how do I know this? This is one of the Pythagoras identities that you were required to memorize. So by now, this should be in your head, like 2 times 2 is 4, okay? All right, so I currently have cosecant square of 66 minus cotangent square of 66. If I were to subtract cotangent square to both sides, okay, I'm going to end up with cosecant square of theta minus cotangent square of theta, which is this identity. So this right here, because of this identity, it comes out to be 1 based on your identity. All right, so again, rewatch this clip right here, this piece of notes, if you don't understand it. And that is the end of our note today. How about a joke to end our session, okay? Why was the man running around his bed? Okay, so why was the man running around his bed? He wanted to catch up on his sleep. Ha ha ha. All right. Have a good day, and I'll see you guys in class.